and welcome to Thor 3D channel, and in today's video we're gonna review some of the most frequent mistakes new and experienced users of our scanners make. First, let's take a look at ribbed surface. What causes it and how to avoid it. Here on the screen you can see some examples of a ribbed surface. Sometimes, once a 3D model is finalized, a user can spot some lines or ridges that shouldn't actually be there. This usually happens when not enough data was captured during scanning. There's two reasons why it occurs. The first, scanning wasn't smooth and the object was scanned either too fast or in jerking strokes, and the second one, when the scanner was set on a tripod, wasn't moved around its axis and was capturing data in a static fashion. Here's an example of such surface. Let's explore what caused it. When this statue was scanned, the scanner was mounted on a tripod. It wasn't moved at all, and it stayed on the same spot, still and untouched. The light grid was being projected onto the statue, and since only the horizontal lines are data lines and are captured, only they stayed in the point cloud, making it look as if multiple layers are stacked on top of each other. Had we scanned the statue in a dynamic fashion, moving it with our hands, the point cloud we would get would look something like this, free of any gaps. And this is a nice smooth model we would get in the end, with no lines, ridges whatsoever. Your movements during scanning must be smooth and slow-paced, as if you're slowly trying to cover the object with paint, trying not to miss any spots. As it was shown in one of our last webinars, the structure light grid consists of a ton of horizontal and vertical lines. But only horizontal lines are data lines. The vertical lines are here only to help sync the grid. They aren't being captured. We always recommend rely on your scanning skills first and then on the software capabilities, because the proper scanning always guarantees a good result. You can learn more in our recent webinar that you can find linked below. Another example is when scanning was incomplete, and the point cloud in that case would turn out sufficient in one areas and insufficient in others, with dense point cloud in sufficient area and patchy with a lot of gaps in other areas, which will surely render equally bad surface on the final scan, with lines, ridges, and holes. Let's discover ways how to avoid ribbed surface. I'm gonna scan one object in two fashions, in a dynamic fashion and in a static fashion. Also, I'm gonna capture about the same number of frames, and you'll see the sheer difference in quality between those two. Let's start scanning in a static fashion. I'm not moving the scanner at all, it's mounted on the tripod and is just capturing data statically. I'm gonna capture about the same number of frames, statically and dynamically. Scanning things statically, you can see that neither the scanner is moving nor the object. It could be rotated on a turntable, but I'm not using a turntable here, it's just on its place. And it's already apparent that there will be lines on the final model. And now let's scan in a dynamic fashion, and so I'm going to twist my wrists to capture data at different angles. In this case, I'm rotating it around its axis. I'm trying to capture the bottom of the object, the top part of it, the right part of it, I'm letting the scanner see the object from different angles. I'm rotating the scanner itself, twisting my wrist, and as you can see, that way helps me to capture as much data as possible, as much quality data as possible. Here's how the two projects will look like, and I want to remind you once again that I took the same number of frames in both projects. I opened the frames and they already look significantly different to each other. The static frames look like cutouts of an object with big gaps between each other, and the dynamics frames look more dense and as if they have more data, and they indeed do have more data captured. There's no holes, gaps, or anything of that kind. Let's finalize both projects and see what we'll get. The first model is done, and this model was captured in dynamic fashion, and so you can see that the whole surface is smooth. There's no ridges, gaps, any holes in it. So that's the quality we get when we're doing scanning properly, when we scan dynamically and twist our wrist. The second model is done as well, and here we can straight away see the lines. That's what you get when a scanner is kept still, isn't moved by hands, and just keeps capturing data statically. The algorithms of Calibry Nest try to do their best and patch the holes, all the gaps with polygons, but as you can see, it's not enough, and the whole model looks just hideous. And I'd like to remind you that I captured the same number of frames, I used the same settings, but the only difference is that during dynamic scanning, I was twisting my wrist, and that is what allowed me to get a better surface. Next example is a model that contains both kinds of data that we captured fast and abruptly, and the one that we captured slowly, steadily, and we hovered over the areas for long periods of time. And in the former case, there are lines, and in the latter case, there's plenty of data. If there's really low amount of data like that on your surface, and it wouldn't make sense to rescan something, you can fix it with some of the tools of Calibry Nest, like smoothing, fill holes tool, or changing the resolution of the whole scan. In the settings menu, you can play around with settings, like tuning the sharpness all the way to the left, change resolution. If we decrease it, the entire surface will be smoother. Also, changing sharpness setting helps you to get a much smoother surface in some cases. And if you go all the way to the left, the surface will be smooth, but it's applicable only for scanning something that doesn't have sharp edges. Let's say like human bodies, vases, anything that is smooth by itself. But if you're scanning something like an industrial part or something that has way too many sharp edges, you should go and tune the sharpness dial all the way to the right. So choose settings wisely. Let's refinalize this project and see what different settings can do to a project. Here are 3 3D models we got by using different settings. In this example, I tuned the sharpness dial all the way to the right. And because of that, the 3D model is coated in coarse surface with visible lines. And the other model is much smoother because we used lower resolution and tuned the sharpness dial all the way to the left. You can see it with the naked eye, the surface got much smoother. If rescanning is not an option and there's still lines on the project, you can try getting rid of them with the built-in Calibry Nest tool called smoothing, which does what it's called. It just smooths out the surface. It really comes handy when the accuracy isn't that important and all you care about is beautiful 3D model, beautiful smooth 3D model, and then you can just smooth it out. Let's say you want to get a nice 3D model of a statue and you don't care how accurate it is to the real statue, you just use this tool. But if accuracy level is important in a particular case, it would be much easier and faster just to rescan the object once again. This is all for now. Thank you for tuning in and see you next time.